In week 3, we will move to Module 3. This week, we will continue to implement an array class, but that will be a little different. We call that array template class. So that will be a static array template. So the first thing I will explain what is the template. So in this module, actually, we need to overcoming some limitation from the previous assignment. Remember, in Module 2, you implement your first array class. But this array class, you only can create an object. An array object only contains int data type, and the capacity is only 100. So we will try to overcome those limitations. For example, can I create an array for different data type? Second, can I change the capacity? Instead of using 100, can user define any size of the capacity for our array? The answer is yes, we can. So that's why in this module and the next module, the first thing we will write a template array class. So in this week, we will write a template array class. We will have the array class, we can create any data type array. But the limitation is we only have the specific capacity number. Then next week, we can define a template array class, but we can allow them to automatically change the capacity when they need. So the first thing, let's see how the template array class should be. So that we see the overcoming limitation in detail. So here, like earlier I said, the array class we have from last week in assignment 2, we define only int data type, and we have a fixed capacity. Actually, we only have the capacity is 100. So how should we accommodate the change to make our new array class actually can be any different data type? On the other hand, actually, user can specify, I want to have my array element is int, or string, or double, or any user-defined data type. So how should we accommodate that? And also the other thing is, in our array class from Module 2, they only have the capacity is 100. So it's possible we can have other capacity. Can we allow user to specify the capacity when we create the array? So that we will do for this week. So in this week, we will try to modify our array class for this version to have different data type. And when we create the array, we can allow different capacity. So this one actually is, I want to remind you, if you remember in 165, when you in the prior C++ courses, we talk about the standard template library, stand for STL. Remember, we introduced you, they have the array class and vector class. So here we will see the first thing. If you remember, if you have array class, if we include the array angle bracket array from STL library, so then actually they have an angle bracket specify the data type and the capacity. So this one actually is from the ST library after C++ 11. And also, did you remember you learned about the vector in 165? When after I include vector library, when we define a vector object, just after the vector keyword, you have an angle bracket to specify the data type you want to have in this vector. So then you have your object name. Then you have the parentheses to specify how many elements you want to have in the vector object. Right, so that's what we have in 165, what we learned about the array STL. arrays template library and the vector template library. So here, why we call they are STL. That's the template for the T stand for, mean in the angle bracket, you can specify the data type you want. So what we have actually here, I show you on the right here, they are the STL library from C++. Then on the left, actually is the limitation we want to overcome. From last week, when we have our array A, right? Our array A, actually, we only define this array A data type is int. Then the capacity is 100. So this week is, we want to make the change. Actually, what we want to implement our array class is similar like the C++ array. We want to have our array can specify the data type, can specify the capacity. So that's our goal. So that's what we want to implement, a new array class. So next, actually we need to ask is, how can we implement a template class? So like we say, the template T stand for, you can have any data type. So that's why in C++, we allow you can define a class. And also we can allow you to define a template class. So what is the template class? In C++ coding feature, a template has similar usage as the generic in Java. So in C++ we call template. In Java we call generic. So they have different compiling technique. But one thing is, if you have any function or class, they can accommodate all the different data type. So then we need to implement this class become a template class. The C++ implementation is a little different but more efficient than the Java code. The C++ implementation actually is, we have our template class, we allow you to replace the T for any data type. So what does that mean? That's what we mean here. So this one is on the left is what we have in Module 2. Did you remember in Module 2 you have your array class? We only define int data type. So then values is the array name. So then we have the 10. So the 10 actually is in our reading pages. But in your homework assignment, we make the capacity is 100. So we have the dummy. Yeah, we have the capacity function, we have the constructor function, then we have getter function. So now on the right, actually I just want to show you how we will make our regular class become a template class. So the first thing is, like we say, we want to have different data type, right? So since we want to have different data types, you see here, actually the integer data type we are fixed the type, data type in the class array is because we define the array we want to use is integer data type. And the element for the dummy, right, is also integer data type. So that's why actually what we want to do is, can I try to replace the int with any other data type? Right, so that's why we call is the template keyword. So whenever we want to write a class, non-template class become a template class, the first thing is we need to add a template keyword. So this template actually is a keyword in C++. So you have to write that if we want to write a template class. So afterward, you need to specify what kind of template data type name you want to use. So that we use the template keyword, then followed by an angle bracket. So this angle bracket, we will specify what kind of value you want to replace. So here we have the type name. So this type name actually give them a variable name. So here we call V. So here type name V just mean the data type you want to replace become a generic one. For example, in our array class, did you see our data type is int? Right, so now actually let's replace this one with the V. So now you will see V is our array data type. V is our dummy data type. Then you go back to see again. In our member function, we have the capacity function. We have the constructor function. So capacity function, we will return the size of the capacity of the array. So then here we have the operator function, getter function. We will return the type of our array, right? So that's why here, after we add this V, we know actually if we allow this array can be any data type. So that's why here, when we have our array getter function and the setter function, we need to change become V as well. Then if you have reference, you still do the reference. Okay, so you see, we just replace a generic variable to replace the int. So later I will show you how this V can replace with any data type. So here the V actually just like a symbol there. We mean later we need to update they are all different data type. For example, think about if I want to write an array class. In module 2, we only allow the integer data type. So now maybe I want the double data type. Right, so what we should do is we need to define this one is double, right? So then I have a double array. So then I need to define the dummy is double. So then I can assign the value to a double data type because array element, each one is double. So the same thing, your constructor function and the getter function, they are the double data type as well. So then you find out actually, if you want to change for any data type, you just need to change everything like here. Okay, so let me do more. So of course, array data type we need to change. Dummy data type we need to change. And also our getter function, setter function. We also need to want to change all these four become other data type we want. So in other words, in our template class, we just need to add the template keyword. So this V actually just a symbol in the future what kind of data type you want to replace. Sounds okay, right? And also one thing is, like earlier I said, in our old array version in module 2, the capacity size actually we just put in the 10 here or 100. How about I want then can be any value later user define. Right, again, I need to have a variable, right? So right here. So then actually capacity, what is the capacity for any array? That's the integer value, right? So right, so here I define an int data type. So here I have a cap, so cap. So this cap actually is the value I can specify. So then later my array can be size, can be capacity 50, can be capacity 100 or 1000, so I can define. So that's why after the template angle bracket, the type name, we add another variable called int cap. So this int cap actually will replace beginning how many elements I want to create for my array. And the capacity function, I should return the cap value. So this one actually is our first template array class, the public interface. So this one is our new template array class declaration. So then the next one we will see each member function. How should we implement that?